So now I'm making a really quick summary over chapter 3, acids, bases, and salts. We have it tomorrow with us in our exam for the periodic. They're not that hard. There is a bit of memorizing, but generally they're really easy. So first of all, chapter 3, of course, we know this. And let's start. For first thing we need to know is what are electrolytes. An electrolyte is something that will dissolve and give off ions, or well, a conducting solution. Which is a solution that contains ions. By the way, guys, for the other chapters, chapter 1 and chapter 2, for chapter 1, go to the video that I made from last periodic for LCP. And for chapter 2, you could go for the video I made for that AMS about it. They're the same material, it's all memorizing. So, yeah. So now we have two different types of electrolytes. We have strong and weak electrolytes. Strong and weak. A strong electrolyte dissolves fully or exclusively, as you might see it. Fully / exclusively. Whereas a weak one will dissolve partially. Okay, so where was I? Okay, yeah. So we have weak and strong. One example of weak electrolytes would be water. Water is a weak electrolyte and it has an equilibrium constant that needs memorizing. Equilibrium constant is equal to Kw, this is what they call it, and it's equal to 10 power negative 14 at 25 degrees Celsius, or you might see it as wait, let me see if I'm right. It's somewhere in the questions here, I swear. It should be 298, yeah, 298 Kelvin. So these are our constants, or this is the constant I mean for water at this temperature, 25 degrees Celsius or 298 Kelvin. And we know that this means that you have the concentrations of OH minus and concentrations of H plus are equal. Each one is equal to 10 power negative 7. Because this is 10 power negative 7, this is 10 power negative 7. Add them together, you get 10 power negative 14. That's how you do it. Now, we have two different definitions of OH and H+, or, well, of acids and bases. You have the Arrhenius, I don't know how to spell his name, to be Arrhenius definition. So, excuse me if, I pronounced it wrong. This one is the one where it tells us that an acid is anything that increases concentration of H plus ions in water. That's this guy's definition. Now, do you need to memorize the guy's name? Probably not, but in case, memorize it. Oh, by the way, and a base is the exact same, but increases OH ions. And now you have Bronsted-Lowry. By the way, excuse my handwriting, my arm's injured, so if it's bad. Bronsted-Lowry's definition is the one where it says that acids are proton donors and bases are proton acceptors. That's both of their definitions for it. Now for the acids and bases, we need to know how to calculate them. Now listen, if they give you any equation like NaOH and they ask you for concentration of OH minus and H plus, be very careful what to do. If they ask you for, let's say they told you have 0.200 molar of NaOH, this. If they ask you the concentration of OH minus molecules, it is this number, 0.200 molar. That's it. But if they ask you for hydrogen, here's what you do. You do 10 power negative 14 over this number, 0.200. And then you're gonna get your answer. Then, so look, when you see in the thing they give you OH and they ask for H, do this. If let's say you have HCl, which is also 0.200, H would be, or concentration of H plus would be equal to 0.200, and OH, you would need to do the formula. So they're kind of reversing, okay? So it would be 10 power negative 14 over 0.200. See what I mean? So as long as you know how to do this, I think Tariq made a video about this one's quiz yesterday. Watch that. All the questions are the same, or like there's many questions that have this formula in it. Solve them, you'll be good. Now, yeah, so this is how you calculate them. Now pH has this formula. Let's look. pH, you do negative log delta H plus. So no matter what they give you, you find the H plus or concentration of H plus, and you're gonna put it like this, okay? Then you're gonna find your answer. If pH is under 7, you have an acid. If pH over 7, you have a base. If pH equals 7, you have a neutral substance. Okay? Now, look, if they give you the pH, let's say they gave me a pH of 5, then H would be, concentration of H would automatically, without even thinking about it, equal to 10 power negative 5. If they gave us H plus to be 10 power negative 8, without putting it into your calculator, your pH will equal to 8. See what's happening here? The pH is the negative exponent of the H. And that's it. And how do you know it's not negative number? Because pH can never be negative. You can't have negative pHs. Like you could, but like, forget it. It's not for our grade level, and it's really rare, and they're not gonna get us anything about it. It's not required for us to know. Now we need to know a few properties of acids. Like acids can react with. Now if you want to know like a few things about acids, I'm gonna tell you them like talking wise. Acids are they have H plus ions, we know that. They're sour, that's how they taste. I wouldn't say sting, but like they're sour, that's how they taste. And they feel, I forgot to be honest how they feel. Like they feel not sticky, I wouldn't say sticky, but nobody actually ever mentions. They're corrosive sometimes. They're harmful to the person. Bases, they release OH ions. They're bitter. They're slippery. Where you can find bases is in soaps, shower gels, dishwash soaps. Like any soap. That's where you can find bases in it. But anyways, now let's go back to acids and what they react with. They react with, first of all, metals. Metals plus acid gives you a salt plus H2 gas. That's it. Now you have 3 different types of acids that you could have. Hydrohalic, hydrohalic acids, these types of acids produce metal halides as your salt. Then you have nitric acid, produces metal nitrate. And then you'll have, by the way, these are the names of the acids, okay? And these are the metals that they make. So these are your acids, then you, with any metal. And when you have sulfuric acid, it will form metal sulfates. Okay? Now, I'm gonna give you the net ionic equation for acids with metals, okay? Let's imagine metal being used as Mg. Mg as a solid is gonna react with 2H plus, aqueous, to give off Mg 2 plus and H2 gas, because we said, this is aqueous by the way, because we said a metal plus an acid. Now usually you'll have an acid like a hydrohalic acid, which is hydrogen chloride, let's say, which will give you magnesium chloride and hydrogen. But here we're not really gonna care, because this is your net ionic equation. So this is the simplest form of the ions in any metal acid reaction. Now let's go on to our next one, which is acid and base. Base plus acid. By the way, this reaction has a name. Will form a salt and water. First of all, this is called neutralization reaction. And when you have a strong acid with a strong base, your neutralization reaction is always H plus OH minus makes H2O. Okay? Let's say you don't have a strong acid with a strong base. Let's say you have NaOH. Or well, you do have here actually a strong acid and a strong base. This is non-net ionic equation. This is net ionic, okay? Plus HCl. You're gonna have, or well, not equal, sorry. You're gonna get NaCl, which is table salt, iodized table salt, and water, H2O. So these, I really recommend you go back to the notes and have them all memorized. So these are when you have bases and acids. Now, let's see carbonates. Okay, so last one, carbonates plus acids. they will form CO2 gas. And what? And the salt plus water. Like for an example, we have okay, here I could give you the net ionic equation, but I'll give you an example and the net ionic. So here's our example, which is total equation, not net ionic. MgCO3 plus 2HCl is gonna give us MgCl2 plus CO2 plus H2O. I'm gonna move it down so you don't get mixed up with the other equations. Okay. Now for the net ionic, it's gonna look something like this for this equation. Plus CO2 plus H2O. And these are all your acid reactions. Then you have a few CQDs in your notes. Solve them, they're easy, they're not that hard. And if you don't know them, open the answer sheet. And yes, there is answer sheets. I don't know how some of you aren't finding them, but I swear there's answer sheets on SDP for them. Then if you don't know them, open the answer sheets. And if, let's say, you find them really hard to do and you really need help with them, write the CQD number in the comments and I'll make a video about it, explaining it. So now we're gonna go into some of our last points, which are indicators, which are just substances that give off colors in different acids, bases, or neutral reactions. And after that we only have like a few points and we're done like for chapter 3. I'm gonna make a video about topic 1 also, I hope it's not that hard. Now, an indicator is a substance that changes color. When you put it in an acid or base. When put in an acid or base. Now look, I'm gonna write down a table, memorize it, because these are our acids and these are our indicators that we need to memorize. So I'm gonna draw a square or a rectangle actually. Let's hope this fits everything. Okay, this side's definitely not fitting anything. What happened here? No, I erased everything. It's fine, I'll redraw it. And like that, and then you have big space for the names. Then we have our acids, our base, and neutral. Okay. Now, these are our indicators. Our acids. These are gonna be the colors in acids, neutral, and bases. memorize this table. So I'm gonna color code it, like write it in colors so we'd understand them. Now we have litmus. Litmus in an acid is red. In neutral, litmus is, I'm gonna change this to purple. In a base, it is blue. Now, we have the thing, I'm not gonna even try pronouncing its name, but memorize how it's written. Thymolphylline. Thymolphylline. I think that's how it's pronounced. Like names, I'm bad at, so don't like come at me. This is colorless in acids. It's colorless in neutral. And it's blue. Well, we're gonna write blue different. Oh my gosh, what keeps happening with this? Huh? Okay, this is actually weird. I'm just not gonna try erasing anything. Blue. Now we have methyl orange. Which is red in acids, orange when neutral, and yellow in bases. And now last one, another one where I'm barely gonna attempt to pronounce. Phenolphthalein. This thing, it's colorless in acids, colorless here, and it's pink in bases, so pink. So look, how I know them is you have two very long names. The two very long, hard to pronounce names are colorless in acids and neutral. The one that starts with TH is blue, and the one that starts with P is pink. P for pink. That's how I memorize these ones. So, yeah. And methyl orange, if it's methyl orange, its base color is gonna be orange. A base, which is closer to neutral, well, not really, but still. Acids are usually red, and bases are usually other colors. Bases are usually blue. Just memorize this table with the colors, or memorize the one we have in the notes. Both are really good. And yeah, these are all our indicators. Now we could measure pH with universal indicator paper or a pH meter. Universal pH paper, which gives you almost a precise amount of acidic or basis or alkaline or alkalinity. Or you could use a pH meter, which is the most precise one in my opinion. Or actually, it is the most precise one. This one will give you a rough number, not that accurate. Like if you actually need it accurate, I'd go for pH meter. This is practically just made out of, like this one is practically just made out of a mixture of dyes and that react with each specific acidity or alkalinity. And then you have a few CQDs about it. And yeah, then we have how our bases react. These aren't that hard. Memorize them, you'll be good for the exam. So bases are oxides or hydroxides of metal. So bases are oxides or hydroxides. And alkalis are soluble bases. Okay? So bases only react with two different things. They're way easier than acids. Bases react with, I'm bored of the color to be fair, so I'm gonna change it to blue. One, they react with acids, like we said before in the acids. Acid plus base will give off salt and water. And it's called a neutralization reaction. Now then, I'm not going to rewrite this because we already explained it up with the acids. And they react with ammonium salts. So when you see ammonium, which is NH4 by the way, salts plus base form ammonia, or known as NH3 in chemical form terms, plus salt plus water. An example of a reaction with ammonia would be NH4 NO3 plus KOH, which is our base, would give off NH3 KNO plus KNO3, or potassium nitrate, plus water, H2O. This is an example of a reaction with a base. Now we have our last thing is our oxides. Now for oxides, I'm gonna go to another app. Let me take a minute to... Okay, I'm here. So we have our oxides. These are all our types of oxides. The last two, which are your amphoteric and your neutral, memorize them. These two are memorizing mostly. These two, you could infer them like from the question, because acidic oxides are non-metallic, basic oxides are metallic oxides. Now amphoteric, memorize them. They're only ZNO, Al2O3 and PbO only. And neutral are only water, H2O, carbon monoxide, CO, nitrogen monoxide, and N2O. To be honest, I don't know what it's called. So these react with both acids and bases. Amphoteric, they act with both acids and bases. Neutral react with nothing at all. They don't react with acids or bases. Acidic oxides react with bases. With bases are usually they react with and basic oxides react with acids. I think that's it for our things about 3.3. Salt preparation is not with us, guys. The titration and excess method and whatever, these are not with us. And yeah, these are just notes I wrote of the exact same thing I explained now. And that's it for chemistry for chapter 3. Topic 1, I'll be making a video now about it, which is the notes and CQDs and whatever.